In this video, we're going to look at the exceptions to the octet rule. So the exceptions are generally going to be when atoms can have more or less than 8 electrons around it. And the duet rule is not really an exception to the octet rule. Exceptions to the octet rule is when an atom normally wants 8 electrons around it. That would be an exception. So there are times when we can have an insufficient octet. If we draw the Lewis structure for BF3, boron has 3 valence electrons and fluorine has 7 valence electrons times 3. So that's going to give me 24 valence electrons. Boron is going to be my central atom. It is the least electronegative out of these examples. And then I'm going to have 3 fluorine atoms around my borons. And I can connect all 3. That is going to account for 6 bonding electrons, and I will have 18 valence electrons left over. I am going to put those on my outer atoms first. And I have used all of my valence electrons. Now, you might be tempted to form a double bond to complete the octet for boron, but we don't need to. So this first exception is boron is fine with 6 electrons around it. Notice that the formal charge on boron is going to be 0. The formal charge on fluorine is going to be 0 as well. So each fluorine is going to have a formal charge of 0 in this molecule. If I were to make a double bond, so if I were to take electrons here and form a double bond, then now my formal charge will no longer be 0 for boron and this fluorine. That's going to make the molecule less stable. So boron is fine with 6 electrons. The next example is NO. Nitrogen has 5 valence electrons, oxygen has 6, so we're going to have 11 valence electrons. Right away, you might be thinking, that's a little weird. We haven't done a Lewis structure that has an odd number of valence electrons. And NO does exist. And what happens is I can have one bond. That's going to be minus 2 bonding electrons. So I have 9 valence electrons left to work with. So I can do 1, 2, 3, 4, 5, 6, 7, 8, 9. My octet rule for nitrogen is not fulfilled, so I can take a lone pair and form a double bond here. Oxygen has 8 electrons around it, nitrogen has 7, so this second exception is nitrogen is fine with 7 electrons when there is an odd number of valence electrons. So this isn't just for NO. Okay, anytime you have an odd number of valence electrons in a molecule that contains only nitrogen and oxygen, then nitrogen is fine having 7. So nitrogen is fine with 7 electrons when there is an odd number of valence electrons in molecules containing only nitrogen and oxygen. And notice that the formal charge on both nitrogen and oxygen in this Lewis structure is 0. Nitrogen has a formal charge of 0. Oxygen has a formal charge of 0. So these are two examples of insufficient octets. So the first one is boron, the second one is nitrogen. There are no other insufficient octet examples. There's no other exceptions for an insufficient octet. Now we can also have an expanded octet, and this is where you can have more than 8 electrons around the atom. And this happens when atoms have access to the d orbitals. So on their periodic table, it's going to be period 3 and lower, because that's when the d orbitals are going to come into play. Phosphorus is in period 3, so it has the ability to expand its octet. If we draw the Lewis structure for phosphate, I can draw phosphorus in the middle, and that is going to account for 5 valence electrons. And then we have 4 oxygens that each have 6. And then we have 3 more electrons because of the 3 minus charge. So this is going to be 32 valence electrons. I can draw lone pairs on each one of my oxygens. I made 4 bonds. So we're going to have 32 valence electrons minus 4 bonds times 2, which will give us 8 bonding electrons. There we go. And that means we are going to have 24 valence electrons left. I put 6 electrons around each one of my 4 oxygens, so I used all of my valence electrons. Now I can go through and calculate formal charge. Oxygen likes 2 bonds. It is missing 1 bond, so it's going to have a -1 formal charge. We've also seen how it has a -1 formal charge when we go through and calculate it. Phosphorus has 5 valence electrons, and there are 4 bonds and no lone pairs. So it's going to have a +1 formal charge. Notice this gives us an overall charge of -3. This is kind of like an abbreviated bracket. Instead of drawing the big brackets, we can just do this small one right here. Now, when I look at this, I notice that every single atom in my molecule has a formal charge, and that's not a good thing. So we can do what is called minimizing formal charge. And since phosphorus can expand its octet, I can start to form some double bonds. So I can take one of the lone pairs from one of my oxygens and make a double bond to my phosphorus. That takes away the formal charge for oxygen, and it also takes away the formal charge for my phosphorus. Notice I still have a formal charge of -3, but now not all of my atoms have formal charges on it. Let's look at another one. We have sulfate. Sulfate and oxygen both have 6 valence electrons. So we'll have 6 times 5 essentially, 4 for the oxygen and 1 for sulfur, and then we'll add 2 electrons because I have a 2 minus charge. So this is going to give us 32 valence electrons again. I'm going to put sulfur in the middle, 4 oxygens on the outside, bond all of them together. That is going to account for 8 bonding electrons, and I will have 24 valence electrons left over. This looks really similar. It really does. So I can put all of the rest of the valence electrons on my oxygens as lone pairs. And now I have accounted for all of my electrons. If I go through and calculate formal charge on all of my atoms, all of my oxygens are going to have a -1 formal charge. My formal charge of sulfur is going to be 6 minus 4 minus 0, which gives me a formal charge of +2. So I'm going to write the +2 and circle it. You should never have a molecule or polyatomic ion that has a formal charge of greater than +1 and less than -1. So the magnitude of your charge should never be greater than negative or than 1. So even though all of my charges add up to -2, this is not a good situation because, first of all of my atoms have formal charges, and secondly, sulfur has a +2 formal charge, and we do not want to see that. So just like I did with my phosphate, I can start taking some of the lone pairs from oxygen and form double bonds. When I form one double bond, I can make the formal charge on the oxygen go away. And now, instead of 4 bonds, I have 5. So that's going to give me a +1 formal charge. I can do this again and add another double bond. Now, my sulfur is going to have 6 valence electrons, but now it has 6 bonds, so my formal charge is going to be 0. Notice I didn't change the overall charge of this structure, I just minimized the formal charge. Here are some more examples you can try on your own. If you have questions about them, please do not hesitate to ask.